Today, we're diving into a lesser known but fascinating sorting. It is called pigeonhole sort. It's simple, surprising, fast under right conditions, and perfect for learning how distribution-based sorting works. Let's jump right in.
Pigeonhole sort is a sorting algorithm designed for situations where you have first is a small range of possible values, and second is uh, a lot of elements that fall within that range. So it based on the ideas on pigeonholes. Imagine you have one pigeonhole of slot. So for every possible value in your data set, so every element goes into the hole that match its value. So
Step 1. Identify the range. First, we need to find the minimum and maximum values. This tells us exactly how many pigeonholes we need. Step 2. We create one pigeonhole for each value of the range. For example, if value goes from 4 to 6, we create holes 4, 5, and 6. Step 3. Next, we loop through the data and place each element into each matching hole. Step 4. Finally, we walk through the pigeonholes in order and collect the elements. Since each pigeonhole represents one unique value, the result is already sorted.
Time and space complexity. In the best scenario, when the range of value is small and densely populated, pigeonholes run is O of m plus k. Time, where n is the number of elements and k is the range of size. Where whatever there's a catch in use, O of k space when it can get larger quickly. So this algorithm is efficient only when the value range is small. You should use pigeonhole sorts when values are integers and the range is small. Many values are repeated and dense. This makes it perfect when things like sorting tests, sort, categorize, and age organizing small integer-based IDs.
Hello. So today I'm going to explain the code tracing of our assessment pigeonhole sort algorithm. So the pigeonhole sort counts how many times each value appears, then writes the value back in order. It's greater when the range of input value is small compared to n, which is the minimum and the maximum. So first of all is this line. This method sorts the array of the length. So here it finds the minimum and maximum. So next is the next it analyzed it it initialize minimum and maximum to the first element. So next it's loop through the array to find the actual minimum and the maximum value. So for example, we have here is it finds the minimum, so the minimum is 2, so the maximum is 8. So next is to next here is the range, compute and create pigeonhole. So range is the number of distinct value between minimum and maximum inclusive. So p-hole is an integer array used as a counter, or so-called histogram. One slot per value. So so just like in um at array, with it always starts with 0. So here we have 1, 2, 3, 4, 5, 6, 7. So basically we have 7 value. So what happened is it corresponds the slots. So it starts with 0, so the slots the array slots will adjust to 7 because it starts with 0, 1, 2, 3, 4, 5, 6. So next is count. So here so next is here it counts each element into its pigeonhole. So array I minus minimum maps a value to correct index in p hole. This line increments the counter for that value. So if your input is like this, so the value equals index is starts with the minimum of 2 equals 0, then 3 equals 1, then 4 equals 2, then 4 is 2, then 7 6 equals 4, then 7 equals 5, then 8 is 6. So the counts pole is 1 1 1 0 1 1 2. So 5 is absent. So next is to reconstruct the sorted array from pigeonholes. Here is the line. It iterates j over each pigeonhole, each possible value, while p hole j is greater than 0. Use post decrement. So the expression returns the current value of p hole j and then decrements it. So the loop run exactly original p hole j times. So each iteration writes the actual value of j plus minimum into array at the next index. So for example, as I explained earlier, the 2 is equals to 0, then the 3 is equals to 1, then 4 is equals to 2. So what happens is p hole, so the value of here is 0 is equal right to here. Next is increment. So next is p hole 1. So 1 is the value of 3. And so on and so on until the final array becomes order. So here is the output. So 2, 3, 4, 6, 7, 8, and 8. So so the time and space complexity of this sort or algorithm is O of n plus range, because one pass to find minimum and maximum, so one pass to count to O of n and O of range to output sorted values. So the space complexity is O of range additional memory for p-hole. So pigeonhole sort is efficient when range is small compared to n. If range is greater to n, example, sorting two numbers that are plus 1 million apart, so it becomes impractical. So that's all part of my explanation of our example of our code tracing.
So that's pigeonhole sort. It's simple, fast under the right condition, and great example of how we sort by distributing rather than comparing. So while you won't use it every day, it is a powerful concept that helps you understand how more advancing sorting algorithm work.